Hi, Mr. Bledsoe. I'm doing the Unit 4 video project, and I got the parent function, the absolute value of x, and this is the graph of the function, the parent function, and it's just meaning it's the origin, and it's v, which how I remember it is the v, what if it closed up like this, and just the straight lines go to this, and it'd go like from here, or like from here to here. And I don't know, I just remember it that way. That's the easiest way for me to remember it. But that's how I remember it. And so I already have the domain, range, and asymptotes written down for this because I just remember them because this is the easiest way for me to find the transform function is by remembering how and what the parent function, domain, range, and asymptotes are. So the domain and range of this function are very easy considering it's a two-strain graph, which the two lines, it means they can first of all mean there are no asymptotes because the only way an absolute value graph can have an asymptote is if it had an asymptote without the absolute value. So it'd be something like the absolute value of y equals absolute value of 1 over x. And I actually further researched that because I thought for the longest time that the parent function of y equals the absolute value of x could have an asymptote because I just really thought it could. But then I remember you telling us that the only way it could have an asymptote was if it was a graph such as like so, which touches 0. And so it has to touch the 0 on the x-axis or the y-axis depending on what the graph is. And so the y equals 1 over x, or y equals absolute value of 1 over x. It has a vertical asymptote at x equals 0. So, but back to domain and range, the two lines coming from the origin, which are the parent function, they will continue to reach infinity negatively or negatives and positives. So this is going like from the negatives here, but going positive there. And then this is going positively and positively. And if you were to give the parent function a vertical reflection, it'd just go down like this, and it'd do the same thing. Nothing would change. So they just keep going, and the positive side keeps going, and negative side keeps going. And this means the domain and range will use any and all real numbers. And now we'll move on to the transform function, but, I already talked about the asymptote, and the asymptotes, there were none, so yeah. So I'm moving on to the transform function, and the function that I chose was -2, or y equals -2, absolute value x plus 3 minus 1. So the first thing I'm going to do is break it into pieces. And the negative sign means reflection. And honestly, just breaking this apart really does help me. And this right here is a stretch or compression of 2. And the 3 right here, this is going left 3. And the -1 right here, that means I'm going down 1. Okay. And I pretty much just summed all that up. I have my script right here because it's so much easier to look and remember what I'm trying to say. And so the final step, which is to move the new function. So once you have completed these transformations, you'll be able to find the domain, range, and asymptotes, which I'm actually going to show you how to transform the function. So what you're going to do is you're going to go ahead and reflect it. So your new graph is going to, or your new thing is going to be right here. I'm just going to draw dotted lines because I don't want to actually draw it. I hope you can see that. Okay, so that's my reflected function. And then you have to stretch or compress it, which I usually wait to do that until the very end, until I move. And then you're going to move it left 3, so 1, 2, 3. So that'll be my center point, and then down 1. So my graph's right here, and I'm going to compress it, which is going to make it a little bit bit skinnier and longer. So there and there. Ooh. Like that. And the arrows will keep going on forever and ever and ever. So that's your transform function right here. And I mean, this leg can be long, it doesn't matter, the leg can be all the way up to here and still have an arrow. And it'd still be the exact same thing because it's still going on forever. So either way, it really doesn't matter. Okay, so the domain, which will be all real numbers, and because it keeps going forever, so I mean, what's there to put other than all real numbers, right? And then the range, since the graph starts at 3, 1, all real numbers will be greater than or equal to 3, so you can either write it like this, or negative 3, yeah, will be greater than or equal to negative 3, or you could write y is greater than or equal to negative 3. Try to make that a little bit neater. Okay. And then the asymptotes, sadly, there is still no asymptotes, and there's nothing we can do about it unless we put a 1 over it, or we have it's going like straight through the x or the y. And so it doesn't have any asymptotes, so we're just going to write none here. And so basically everything I just did, like in a summary, was I found the domain, range, asymptotes, and I actually graphed the function. And graphing the function really does help it a lot. But that's my Unit 4 video for my extra part of my test, and thanks for watching. Bye!